Question number 5. Diagonals of a parallelogram intersect each other at point O. So as you can see, this is quadrilateral ABCD, which is a parallelogram where diagonal AC and BD intersect each other at point O. If AO is of 5 unit, so this AO is of 5 unit, BO is of 12 unit, and AB is 13. AO 5, BO 12, AB is 13. So this is 13 unit. Then show that quadrilateral ABCD is a rhombus. Question says it is parallelogram, but we need to prove that this parallelogram is actually rhombus, and that we can prove with the help of a property. According to this property, we know that diagonals of a parallelogram just bisect each other. But in case of rhombus, they not only just bisect each other, but they are perpendicular on each other. So if we prove that this angle AOB is of 90 degree, then we can say that this these eight diagonals, that is AC and BD, are perpendicular bisector of each other, are perpendicular on each other. If they are perpendicular on each other, which means it's this parallelogram is also a rhombus, because any parallelogram where diagonals are perpendicular on each other are rhombus, will be considered as a rhombus. So we can use this property to prove that this quadrilateral or this parallelogram ABCD is a rhombus also. So how we can prove this? Here we getting a triangle AOB, where we have length of AO, BO and AB. If we want to prove that AOB, angle AOB is of 90 degree, we can use converse of Pythagoras theorem. If square of AOBO is equal with square of AB, then we can say angle AOB is a right angle by converse of Pythagoras theorem. So here it is already given certain length in triangle AOB. AB, length of AB is 13. So this way AB square will become 169. 13 square is 169, and AO square plus BO square. Here we can write those two length also. AO is actually 5 unit and BO is 12 unit. So these measurements are already given. AO square, that is 5 square, will give us 25, plus BO square is 12, whose square is 144. So 25 plus 144 again will give 169. So this can be considered as 1 and this can be considered as 2. So from 1 and 2, I can say that AB square is equal with AO square plus BO square. So look at this. The square of AB is equal with square and sum of remaining two sides AOBO in triangle AOB. So this, because of this, I can say therefore angle AOB is of 90 degree, because this condition is possible only in right angle triangle as per Pythagoras, and reason we can give converse of Pythagoras theorem. So this angle AOB, we're talking about this angle, this is 90 degree now. If this angle is of 90 degree, so here on the basis of this information I can say therefore AC is perpendicular on BD, and AC and BD are diagonals of quadrilateral ABCD. If two diagonals of a parallelogram are perpendicular on each other, then that parallelogram is a rhombus. So therefore quadrilateral ABCD is a rhombus. Here you can mention that a parallelogram is a rhombus. A parallelogram is a rhombus if its diagonal are perpendicular to each other. So we taking help of this property that a parallelogram is a rhombus if its diagonals are perpendicular to each other, to prove that quadrilateral ABCD is a rhombus. Hope it is clear to everybody. This is question number 6, where question says quadrilateral PQRS and ABCR. ABC is inscribed within quadrilateral PQRS and both are parallelogram. If angle P is of 110 degree, so this angle P is 110, then find the measures of all the angles of quadrilateral ABCR. So we need to find out all four angles of this quadrilateral ABCR, which is again a parallelogram. So it is already given that quadrilateral APQRS is a parallelogram. So if PQRS is a parallelogram, then the angle R should be equal with angle P, and each will be of 110 degree. Reason, opposite angles of a parallelogram. So we can use this property that opposite angles of a parallelogram are congruent. We can say that angle R is of 110 degrees, as angle P is already given as 110. So in quadrilateral ABCR, one angle P, we already have. Now besides, so this angle R is also 110 degrees. We found with the help of this property opposite angles of a parallelogram. Now we have three more angles to go, that is angle A, angle B and angle C. So in case of angle B, here again I can say quadrilateral PQ angle ABCR ABCR is a parallelogram which is already given. So here angle B should be same as angle R and each will be of 110 degrees. Again we can use same reason that opposite angles of a parallelogram. So we have angle B as 110. This angle R is also 110. I can say angle A plus angle B is of 180 degree, because angle A and B are adjacent angles of a parallelogram. So angle A and angle B, these two angles should be 180. So here we can say adjacent angles of a parallelogram. Now angle A, we don't have angle A plus angle B. Angle B is of 110. So here we can take 110, which is equals to 180. Keeping angle A on its place, 180 on its place, this 110 can be transposed to the other side. So thereby we can have measure of angle A as 70 degree. So now angle A is of 70, angle B 110, angle R 110. We need angle C. So here we can say angle A is same as angle C. Each will be of 70 degree. Again same reason, opposite angles of a parallelogram. Now we have angle A as 70, angle B as 110, here we have B, Angle C is of 70. A and C both is of 70 degree, and angle A, B and R is of 110 degree. And question was about to find out all four angles of this quadrilateral ABCD, where angle A is 70, angle B is 110, angle C is 70, and angle R is 110. And this is our solution to find out all four angles. Hope it is clear to everybody.